Hi everybody, it's crazy, it's Monday, and it's time for the UPBGE video of the week. Now before I get started, gotta give a shout out to my trusted, because you guys rock, to my crazy fam, I love you guys. Now, it is Autism Awareness Month. As you see, I've got my little my little ribbons on. If you know somebody who has autism, show them a little love and support, okay? So, let's get started. We left off last week on page number 9, using features that are not part of Blender. Okay, there wasn't a file, but I do have one opened because we're going to be opening up this file. I will bring you over here and show you this one here in just a minute, but I'm going to read down a little bit and get you more familiar, okay? So, no man is an island. No game is an island either, except Monkey Island. And the easiest way to integrate your Blender game with the external world is with Python. If you want to use external devices to control the game input or to tie external applications to your game, you may find Python suitable for that task. There are some examples that showcase what can be done with Python external libraries. 1. Grab data off the internet for game score. Control your game with a Nintendo Wiimote controller. Combine head tracking and immersive displays for augmented reality. Those possibilities go with the previous statement that almost everything that you can do with Python, you can do in the game engine. And since Python can be used with modules written in other languages, properly wrapped, you can virtually use any application as a basis for your system. Cross-platform, yes. Cross-version, not. Okay? The use of external libraries, you must know the Python version they were built against. The Python library you are using must be compatible with the Python version that comes with your Blender. It's also valuable to check how often the library is updated and if it will be maintained in the future. Because there are some libraries out there in Python that are very outdated and have not been kept up or have not been used in a long time. Okay, but there are other ones that are updated daily, so you might want to check into it. Okay, so keep track of your changes with a version control system. If you take a Blender file in 2 different moments of your production, you will have a hard time finding what has changed between them. This is because Blender's native file format is a binary type. Binary files are written in a way that you can't get them directly. They are designed to be accessed by programs and not by human beings. Scripts, on the other hand, are plain text files. You can open a script in any text editor and immediately see the differences between 2 similar files. Finding those differences are vital to going forward and backward with your experimentations during work. Actually, if you don't want to check for differences manually, you may want to consider using external script files with a version control system such as Git, SVN, Mercury, or CVN. Okay, I use Git. Actually, the Game 3 engine uses Git, and I use GitHub Desktop, so I can see that the changes that Day does in Game 3, so that way I can keep up with what he's changing, so I can play around with it myself. Okay? And the catch is, this works only for scripts maintained outside Blender. This is one of the strong reasons to prefer Python module controllers as opposed to Python script controllers. A version control system allows you to move between work versions of your project files. It makes it relatively safe to experiment with different methods in a destructive way. In other words, it's a system to protect you from yourself. Okay, I'm going to show you this file here in just a second. Okay, you can see an application of this. Okay, so I'm gonna come down here, over here, and I'm gonna switch to there. Okay, now this file is, what I'm talking about. Someone changed the script file online while we were working locally on it. Instead of manually tracking down the differences, we could use a tool to merge both changes into a new file and commit it. We were using Taurus SDN for Windows here, a graphic interface to use with a SDN system. For Linux systems, SDN command line plus the software meld work just as well. Okay, so this is basically what it is. Okay, and it tells you what has been changed and what you changed. Okay, so these two can actually work together and fix each other. Okay, I'll go back over to nope, wrong one. Yeah, here we go. Okay, debug your game while it runs. Interpreted languages, also known as scripting languages, are slower than compiled code. Therefore, to speed up their performance, they were compiled and cached the first time they run when you launch your game. Okay, this is not mandatory though, and if you are using external Python scripts instead of those created inside Blender, you can use the debug button to have them reload every time they are called. Okay. In figure 7.4, we have the scripts.reloadme.module that we will be reloaded every frame. That way you can dynamically change the content of your scripts, variables, and functions without having to restart the game. Try it yourself. Copy the content of the folder book chapter 7 1 reload me to your computer. So what we're going to do is, okay, you should already have it on your computer. Okay, but what you're going to do is you're going to go back to chapter 7. Okay, you're going to come up here to reload me. You're going to go to that, and you'll see that debug python.blend is right there. Okay, now there's another file. There's a text file here, so I'd advise you to also open it up in a file folder. If I can bring it up here. Yeah. Okay, and I've got it over here. I'll bring it into view. Okay, same script. Okay, debug Python, but this script right here we're going to open up in a text editor. Okay, and that should be this one right here. Okay, and that's this file right here. As you can see, there is no things that you would normally see in scripting language, like the green for these, or the the commands and stuff like that you would actually see over in here. But this is just a text file, so the text file itself is just not going to show all that information. It's going to give you the same stuff. You just got to know where a define is, okay, or where a try is, or an if statement, or anything like that, or what these little asterisk marks are doing. This is doing the same as this right here. Okay, so if you see one of these little pound signs, that means it's being commented out. In other words, it's going to be green in your mind's eye. Okay? All right, so we're going to kick back over here. All right, so the speed of the cube, hang on, play your game and you will see the spinning cube. The speed of the cube is controlled by the 14th line of the file script.py. Okay, so it's the 14th line. As you know, you get a numbering system in here, but if you read on in the book where I'm at, you're going to see it says edit the speed value and you will see the rotation changing. That's this right here. Okay, so that's the 14th line down. So this is where you're going to change it. Okay, and you see I have mine set to 50 and it's supposed to be 25. Okay, and here it says 0.01 to 0.05. Okay, the 5 behind here is a halfway mark. Okay, it's like a half. It's the difference between 2 and 3. 2.5 is 2.5. Okay, or a quarter of the time. Okay, so we're going to continue on. Okay, now we're going to say without closing Blender or even stopping your game, open the file script.py in a text window. So I ain't going to be able to show it to you, the text window, because I'll have to switch between screens, like really fast here, doing like this, okay, which would be a pain in the butt. But if you hit play right now, you'll see the cube is spinning at 0.5, right? I haven't saved it to 25 yet, but watch this. As soon as I hit save over here, over there. There. Somewhere that way. But anyway, as soon as I hit save, you'll notice that the cube slowed down. Okay. Now, if I put it back up to 5 and I hit save again, it will pick back up speed. So you can dynamically change it. Okay. So what I'm going to do is I'm going to come back over here. I'm going to read while you see the fast spinning cube to hypnotize you. Okay. So see, without closing Blender or even stopping your game, open the file script in the text editor, change this line to 0.05, for example, and save it. You will see the speed changing immediately. Your game is literally being updated at runtime. And you can change any module that's been called with the debug option on. Okay? Turn it off when you leave. Remember to turn debugging off when you are done with this script. Reloading the script every frame can drastically reduce your performance. Okay? So I'm going to come back over here and I'm going to hit escape to make it stop. Okay, what it's talking about is you don't want this to keep loading because it's sitting on it always. So it's going to always do it every frame. Okay, every single frame. So it's doing it every single frame. So that's going to really dramatically kill your performance if you have the debugging on. Okay, and you know about debugging because we went through that in chapter, I think it was 2 or 3. Okay. So what I'm going to do is I'm going to stop it here because we're at that 11-minute mark. And I'm going to switch over to here, show you where we're going to be at. So what exactly is Python next week? So we're going to go ahead and kick out of that. Okay, and that is page 11. Okay, we're up to episode 111. Ooh, the ones are happening today. Okay, so page number 11 next week. So what exactly is Python? We'll see you next week.